Hi, ladies and gentlemen. This is lesson 9.8 Geometric Sequences as Exponential Functions. And our SWABAT for today is to identify and generate geometric sequences. So, how can you tell if a sequence is geometric? Well, it has a common ratio. How can you find the missing terms of any geometric sequence? Well, you can continue to make the sequence, but if it's one of those terms that's like 100, that would take forever. And so there's this nifty formula that you'll want to write down. And in a later example, we'll talk about how to use it. So our first example today is to determine if the sequence is arithmetic, geometric, or neither. Alright, so for our first example, I'm going to try to find out if it's geometric by finding out if it has a common ratio. 8 divided by 0 is, actually it's undefined, isn't it? 16 divided by 8 is 2. 24 divided by 8, oh, that's a different number. So we know it's not geometric because it doesn't have a common ratio. Does it have a common difference? Well, let's find out. 8 minus 0 is 8. 16 minus 8 is 8. 24 minus 16 is also 8, and 32 minus 24 is also 8. Since it has a common difference, common difference is 8, it is therefore arithmetic. Let's look at our second example here. 48 divided by 64 is 0.75, or 3/4. 36 divided by 48 is the same thing, 3/4 or 0.75. And if we check our last 27 divided by 36, it is also 3/4 or 0.75. So this has a common ratio. The common ratio is 0.75. Therefore, we know that this sequence must be geometric. Awesome. Let's look at our second example. So now we're supposed to find our next three terms in the geometric sequence. Let's first find our common ratio. All right, 16 divided by -4 is -4. 64 divided by 16 is -4. So we know when the sequence continues, we would take a number and divide it by -64 and get -4. So to continue it, I'm just going to do the opposite of dividing by -4, which is to multiply by -4. So if I multiply it by -4, my next number has to be positive. It ends up being 256. If I multiply by -4, my number after that would have to be -1024. Again, we're timesing it by -4. And again, if I multiply by -4, my next number would have to be positive 4096. So again, we're multiplying by -4 every single time. And for our last example, we're going to extend this sequence and find the 9th term of the sequence using this formula. This again comes in handy if you're asked to find like the 1000th term or 10,000th term, because you won't have to just do what we did that time and use the common ratio to continue the pattern. So let's first start by finding the common ratio here. 12 divided by -6 is -2. Does that continue? You betcha. So our common ratio is -2. So we know R equals -2. Remember, a sub 1 represents the first term in the sequence, which in this case is -6. And n represents the term number we are trying to find, which is 9. So our job now is to plug those numbers into the formula to find the 9th term of the formula. So again, a sub 1 is -6. Our common ratio is -2. And we're raising that all to the 9 minus 1 power, so all to the 8th power. All right, if I simplify exponents first, then we know we have -6 times Negative 2 raised to the 8th power is going to end up being a positive number because it's an even exponent, so 256. And I can now go ahead and simplify that and find out that my ninth term, a sub 9, is negative 1,536. So that formula comes in handy again when you want to find something way down the line in your sequence and don't want to have to actually work it out to get there. So now you can see I plugged in the numbers, I simplified my expression, and now you can find something way down the line in your sequence without having to work it out along the way. Have fun using this formula.